this section is just about going backwards from what we did in the last section. So in section 6.2, we said we know that this quadrilateral is a parallelogram. Here are its properties, right? In this section, we're going to say, well, if the quadrilateral has these properties, then it's a parallelogram. Yeah, if the quadrilateral has these properties, then it's a parallelogram. So we've already talked about these properties, right? If both pairs of opposite sides are parallel, then it's a parallelogram. If both pairs of opposite sides are congruent, then it's a parallelogram. If both pairs of opposite angles are congruent, it's a parallelogram. If the diagonals cut each other in half, bisect each other, then it's a parallelogram. Right? If one pair of opposite sides is both congruent and parallel. Okay, this one is kind of a new one. Okay, the first four we already talked about in the last section, but this fifth one, we can prove that something is a parallelogram just by looking at one pair of opposite sides. Okay, we can say that if one pair of opposite sides is both congruent and parallel, then it's a parallelogram. Okay, so before we look at this example down here, let's say we have some figure like this, and we are given that these two sides are 10 and these two sides are 6. Is that enough information to say that this is a parallelogram? Yeah. Yes, right? Because we know both pairs of opposite sides are congruent. What if I give you something like, what if I say these two sides are parallel? Is that enough information? If this pair of sides is parallel, is that enough information to say that this is a parallelogram? I heard some yeses and some no's. So if both pairs of opposite sides are parallel, so I only gave you one pair of sides parallel, right? So just one pair wouldn't be enough information, right? So on the homework, the first couple of questions are just questions like this, like if I give you this figure, is this enough information? Okay, what about something like this? What about, let's say these two angles are 50, these two angles are 1/3. Is that enough information to say that this is a parallelogram? Yes, right? We know that opposite angles are congruent. Okay, so something like this would be enough information. Okay. What about, let's do one more. How about if I give you that this pair of sides is parallel and they both have a length of 9. Is that enough information to say that one pair of sides is parallel and that same pair of sides is congruent? Yeah. It is. That's the last one. One pair of opposite sides is both congruent and parallel. If we just have that much information, that is enough to say that the figure is a parallelogram. Okay. So on the front here, the problems on this note sheet are really similar to the ones that we were doing in the last section. So we're not going to spend too much time on these, maybe do a couple practice ones, okay? But the directions are just worded differently, right? It says, find x and y so that this figure is a parallelogram. But we're doing the exact same thing we did in the last section. Right? We're just saying, well, if it's a parallelogram, then we know that opposite sides are congruent. So I can say 6x plus 3 will have to equal 15. Solve this equation for x. Subtract the 3 over. Divide by 6. We get x equals 2. I can do the same thing for the other pair of sides. But to solve this equation, I'm going to need to use my answer of x equals 2. So I'm going to have to plug 2 in here for x. So 4 times 2 is 8. So this will become 8 minus 2y. So now I can say 8 minus 2y equals 2. To solve something like this, I already have my y's on the left side, so I want to bring the numbers to the right side. So I'm going to subtract that 8 over. Get negative 2y equals 2 minus 8 is negative 6. Divide both sides by negative 2. And we would get y equals 3. Questions? Okay, so we're just going to take a few minutes. Okay, we're probably not going to get through all the examples on the front here. Okay, we're going to spend a little more time on the back. So let's just take 3 or 4 minutes. You guys try as many as you can. Okay, but probably not going to get through all of them. Okay, we'll just take a couple of minutes here. Try a couple of these problems.
So when you get there, you have to think like, okay, this and this out. So you plug that in. So what is 11 times 55? 5 is 55, so 5 down is 55. That's when you have to start thinking about what side is 180 and what you can plug in. So now you're set right on the left. Yes, I mean, I'm not but that's okay. But this is going to be on my share for you. Yeah, that'll still count.
I mean, it's a schedule. I read it last night. I read chapter 1.
It's hard though, isn't it? But this book that I put in will be on my share. Well, you read your study hall. You all just have to make those all in your study hall. I didn't.
Why did you have to switch from chapter 5? How would you start number 2? That's because Tyson was already.
And I was doing a bunch of that. First.
I've seen.
So, yeah, so you have to plug in the x. The x is 5, so 11 times 5 is 55.
Yeah,
I think
number 6.
And then set that. So, 5 times 11 is 55, right?
So we know
So
opposite
you could do
angles.
5
Angle
y
and angle
plus
are next to each
55.
other. So we know that these two are equal to each other.
And then you solve from there.
Alright, I know you're probably not done with all 6 of these, okay, but take a look up here at the answers to the ones that you have completed. See how you did. Are there any in particular that we want to take a look at? 5. So, on number 5, one thing that we know about parallelograms is that they cut, or the diagonals cut the parallelogram into 2 congruent triangles. And we said yesterday the 2 angles that would be congruent would be the alternate interior angles. Okay, this is actually something that we're pulling all the way back from chapter 2, where we've got a pair of parallel lines cut by a transversal. We're going to say that alternate interior angles are the same. So my setup would be this angle equals this one. 2x equals 30. Then all I would have to do is divide by 2. We get x equals 15. And to solve for y, I'm going to need to use this, plug it back in. So I'll have 15 plus y. I'm just plugging that in place of x. And then I would say this angle is alternate interior with this angle. So I'm going to say 15 plus y equals 24. Subtract the 15 over. Get y equals 9. Any others on the front here? Number 6. So on this one, we're not given any actual angle measures. We're just told that these 2 angles are congruent. That's what the arcs mean. And then I have to use that to solve for x and y. Well, if I know this is a parallelogram, I know that consecutive angles add to 180, but I also know they're the same. So there's only one possible way for 2 angles to add to 180 and to be equal to each other. That would be if those 2 angles are both equal to 90 degrees. Right? Now, if you don't recognize that right off the bat, what you could do is say, well, I know they're the same, so I could call each of these x, and then I could say x plus x equals 180. Solving that equation, you would get that both of these are 90. So then, I know that opposite angles are equal to each other. So I can just say 3x equals 90 and 6y equals 90. Divide by 3, we get 30. Divide by 6, we get 15. Other 4. So 4 was kind of similar to 5 if we look at x first. So I'm given that this angle is 9x, this angle is 45. So those are alternate interior angles. In this parallelogram, those will be equal to each other. So 9x equals 45. And then divide by 9, I'll get x equals 5. For y, I'm given those as side lengths. So I know opposite sides in a parallelogram are equal to each other. So I can say 6y equals 18. Divide by 6, we get y equals 3. Other questions? So we would be setting opposite sides equal. So my setup for x should be 2x minus 2 equals 12. Then I would add 2 over to the other side. Then divide by 2. 14 divided by 2 is 7. Number 2. So on this one, I know that opposite angles are equal to each other. So to solve for x, I can say 11x equals 55. Divide by 11, get x equals 5. Then to solve for y, these two angles would not be equal to each other since they're right next to each other. They're consecutive angles. That means they would add to 180. So my setup to solve for y would be 5y plus 55 equals 180. Subtract 55 over. Get 5y equals 125. Divide by 5. That's how we get y equals 25. Questions? Alright, let's flip over to the back here and talk about proving that something is a parallelogram. Right? If we are given coordinates of the vertices of a parallelogram, we have 2 methods to determine, well, really 3, okay, but 2 that we're going to focus on. 2 methods to determine if it is a parallelogram or not. The first way, okay, uses the idea that opposite sides of a parallelogram are parallel. So what we're going to do is find the slope of all 4 sides and check to see if opposite sides have the same slope. That would mean they're parallel. So remember, our slope formula is right here, y2 minus y1 over x2 minus x1. Okay, so we've got our parallelogram, or our potential parallelogram graphed over here. We want to just calculate the slopes. So if I want to use my formula for AD, I can make this x1, y1, this x2, y2, and then plug that into my formula to find the slope of AD. So y2 minus y1, 0 minus 3 over x2 minus x1, negative 3 minus negative 2. And remember, we've talked about if we're doing this by hand, we want to put negative numbers in parentheses so that we can keep our negative and our subtraction signs straight. So my slope here, 0 minus 3 is negative 3 over negative 3 minus negative 2. So that would be negative 3 plus 2, which would be negative 1. So negative divided by a negative would just be positive 3 over 1. Okay, so we want to do that for all 4 sides. We want to find the slope and see if opposite sides have the same slope. So we found AD. Right? The opposite side would be BC. So once we calculate that slope, those should be the same. So let's do that. Okay. For BC, I can label x1, y1, x2, y2. Plug them in. So y2 minus y1 is going to be negative 1 minus 2 over x2 minus x1, so 2 minus 3. So negative 1 minus 2 is negative 3 over 2 minus 3 is negative 1. Negative over a negative is a positive, so we get a slope of 3 over 1. AD and BC have the same slope, so that first pair of opposite sides is parallel. We have to check the same thing for AB and CD. We want to see if these 2 sides have the same slope. So why don't you guys take a second and find those 2 slopes here. Find the slope of AB and find the slope of CD. See if those 2 are the same. Bless you. We get negative 1/5 and negative 1/5 for our two slopes. Okay, so what we've constructed is a proof to show that this is a parallelogram. Okay, this is our proof. We've shown that opposite sides have the same slope. So we can say ABCD is a parallelogram because opposite sides have the same slope. Okay. Our second method is to show that opposite sides have the same length. Right? Opposite sides have the same length. So to do that, we're going to use the distance formula. Y2 minus y1 squared plus x2 minus x1 squared. The way we usually write it, and it doesn't matter, you'll get the same answer either way, but we usually put the x's first. But it does not matter what order we write those in. Okay, but this is the way that we've usually seen it. So, we want to find the length of each opposite side. So for AB, I'm going to take my 2 points up here. I can label x1, y1, x2, y2. Plug those into the distance formula. So x2 minus x1 would be 3 minus negative 2 squared plus y2 minus y1 would be 2 minus 3 squared. So we get, that'll be 5 squared plus negative 1 squared. So 5 squared is 25, negative 1 squared is positive 1. So we get the square root of 26 to the length of AB. Now for our purposes, we can just leave it as the square root of 26. We don't need to put that into the calculator because what we're going to be doing is just testing to see if that's the same as another side. And that other side that should be the same is the opposite side of CD. So we're going to find the length of CD as well. So again, we'll just do x1, y1, x2, y2, C and D. Plug those values in. So x2 minus x1, negative 3 minus 2, plus y2 minus y1. So negative 3 minus 2 is negative 5. And 0 minus 1, that should have been negative 1. 0 minus negative 1 is positive 1. So negative 5 squared is positive 25. 1 squared is 1. We get the square root of 26 for the length of CD. So AB and CD have the same length. Right? I want to do the same thing then for AD and BC. Okay, finding those two lengths. And then see if those are the same. So if both pairs of opposite sides have the same length, then it's a parallelogram. Okay. Questions on those ideas? We're about out of time. Okay, so method 1, show that opposite sides have the same slope. Method 2, show that opposite sides have the same length. Okay.